To build packages and write our own nodes, we need to install Colcon, which is a build tool for ROS2. So I type sudo apt install python 3 Colcon common extensions. On my PC, I already have it installed, but again, you'll have to install it. So yeah, do that. Colcon comes with a lot of auto-completion features, which would be really useful later on when we move ahead with building our own packages and stuff like that. So I need to enable that functionality, which, by the way, is not enabled by default, but I just need to source a certain script that's in this directory. So I'm just going to split my terminal here. I'm just going to split it here. And I'm just going to type change directory to user share Colcon our complete hook. And I want to list everything here. So there is this particular script that I would like to source every single time I open a new terminal. So what do we do? Well, we can just gedit -rc, and once again, this is one line of code that I had, one line that I had already added to your bashrc file. So all it does is really sourcing your ROS installation, just to save you time. All right, so here I have to add a new line to source this particular file. So I'm just going to copy this. I'm just going to paste it here. And again, this is the script that I'm trying to source. So that's that. And I save it. And I close this file. Again, let's see if that file actually exists, because if it doesn't, then whenever I open a new terminal, it's going to give me an error. So yeah, there's no problem here. So that's done. So before we start writing our own packages and nodes, we have to find housing arrangement for, well, our packages and nodes, right? And well, all the code we write. So a workspace is essentially where all your programs and all that stuff reside. All right, so let's start by creating a workspace. I'm just going to make a directory here, ROS2 workspace. Again, WS workspace. You don't have to name it exactly this, but again, I'll be using this throughout the tutorial, so I don't know, it's up to you. And let's go inside that particular workspace, that directory. I'm just going to create another directory inside this. I'm just going to name it src, and this shall be the source directory for, well, pretty much all the code we write. So this is where, say, if you compile a code, that would be inside this. All right, so let's just list everything. And again, inside ROS2 workspace, I just have one directory. That's my src directory, right? All right, I'm just going to type colcon build, and yeah, it's successfully executed, right? And it shows 0 packages finished. Well, we haven't really written any packages or anything, so that's completely fine. Let's see what's inside this ROS2 workspace now. All right, so we have a whole bunch of new stuff here. Again, src as before. Again, like I said, this is where all our code's gonna live. Then there's log, where, well, all the log data is gonna reside about our builds and everything. So we have to source one particular script within the install directory here um, every time we use this workspace. So because we have to source this workspace if we want to use any packages and nodes that are uh, from within the workspace, right? So all the stuff we write is going to be inside this workspace, and we have to source it to be able to use it. All right. So where does it really live? I'm just going to go to install, and well, there are two setup files here. That is setup.bash, which essentially sources the entire workspace and the parent workspace of the whole thing, you know, the global ROS installation. And then there is a way to locally source the workspace, but again, for simplicity's sake, we are just going to do this. All right, so I think I'll just split my terminal again. Why do I want to do that again? I just have to go to home directory here. I'm gonna edit my .bashrc file. All right, so I have two sourcing things here. I'm just gonna add another line, source ROS2 workspace. So this has to start from home, right? So home ROS2 workspace, install setup.bash, and I'm just gonna save the script again. So every time I open a new terminal window, this workspace is gonna be sourced. All right. As we have discussed before, packages are functional blocks of, independent units for ROS2 software. For example, you might have a camera package which would have a bunch of nodes for capturing video stream, maybe to downsize the video. That may be another node, or maybe doing some computer vision stuff with it based on the kind of architecture you come up with. Maybe you want to put that in the camera package itself. I don't know. So how do we create a package? Let's just go to our workspace here, ROS2 workspace. I'm just gonna go to my source directory here. And again, there's nothing in here as of now. I'm just gonna create a package. How do you create a package in ROS2? You type ROS2 pkg package create, followed by package name. I'm just gonna name it, I don't know, first package. Then again, there are a lot of ways of building a package in ROS2. You could build a C++ package or a Python package. So we have to specify that. So I'm just gonna type build type amend Python. Now that tells Qualcomm that we are creating a Python package, right? Okay. Now I need to add all the dependencies here. Now, in this example, we're going to use a library called RCLPy, which you'll be using a lot throughout this course. So I'm just going to add that here. So ROS2 package create, followed by my package name. What kind of package am I building? I'm building a Python package. What kind of dependencies do I have? Well, I depend on RCLPy. All right, now that does something, right? It has obviously created a lot of stuff here. Again, let's just have a look at what these things are. I'm just gonna list everything, and of course I have my first package in here. So let's see what's inside that package. Well, there's a directory by the same name there, and there's a whole bunch of stuff there. We'll get to all that in a bit, but so your XML file would have all the details for who made the package, what's the version, that kind of stuff, licensing, all that kind of stuff. So these things can actually be released to either open source community or as a licensed piece of software. Either ways, you would put all that kind of information here. And there's a lot of files here for setting up and everything. We'll go through them. Let's build the package that we just created. For that, I just go to my source directory again for that particular workspace, ROS2 workspace / source. I'm just gonna type colcon build. Takes a while, but it returns this, right? So yeah, one package finished. Again, there's a more specific way of doing it. So this time, this way of doing it would result in all the packages being rebuilt every time you write colcon build. But if you just want to build one package at a time, there's one more way of doing it. That would be colcon build. Just for the sake of convenience for future tutorials. Packages, select. Then again, I can just put my package name here. So my package name is first package. It does essentially the same thing, but yeah, it's a way more specific way of building packages. So finally, we are done with all that, procedural stuff. Creating a workspace, then creating a package inside the workspace, building the package, sourcing everything. And at this point, we have sourced, some 3 things, right? So all that procedural, boring work is somewhat done. They're going to move on to actually writing ROS2 programs, right? So up until now, we haven't really written any code. We have been running stuff. We've been using all these utilities, but we haven't really written any code. So this right here would be your hello world to ROS2. I'm just going to go to my ROS2 workspace. Again, to my source file. Then there's a bunch of stuff here, and here is my package. I'm going to go there, cd first package. And inside that, I have one more directory by the same name as my package, right? So I'm just gonna go to that directory. I keep saying file instead of directory, just pardon me, directory. All right, I'm just gonna go to package. And inside that, we just have one thing. That's the initialization script. That doesn't really contain anything as of now. But we're gonna create our first publisher node. Now, finally, all the code that you're anyway gonna copy paste from somewhere and has already been given to you and has been explained in the slides and everything. Where do we really put that code? Now that's the question, right? So this is where we put all that code, right? The code that we are gonna copy paste is essentially gonna live here in ROS2 workspace, in our source directory, inside our package, and inside the directory that has the same name as our package. So package name, right? Inside that, we're gonna create a Python script. I'm just gonna call this one, say something thing.py. And again, I've conveniently copied everything. I'm just gonna paste it here. So all it really does is that, again, you have to look up the explanation. Everything is posted on your LMS. So it imports RCL-CPP and RCL-Py. Sorry, RCL-CPP is for C++. RCL-Py, and it publishes whatever the user enters. So this is the publisher node, by the way, to this particular topic you see over here, and this is the queue size. Now the queue size is how much the particular topic weighs till the older data in that particular topic is discarded. All right, so the topic we're gonna use is UG26 matters, because you guys matter, and these are, bad attempted upon, but yeah, you get the point. So all it does is it gets a user input, prompts the user for an input, and then it publishes to that particular uh, topic. Cool. I'm just gonna save it here. Now I'm just gonna run. I'm just gonna create a subscriber node, right? For the same thing, subscribing to the same topic. So gedit, what do we name it? Are they saying? Nah, too long. What did I can't really decide on a subscriber name, but I'm just gonna call it listen to stuff.py. And again, I've conveniently copied everything. I'm just gonna paste it here. So again, whatever it does is that it reads whatever message is available on this particular topic over here, UG26 matters, and it prints it on the terminal. All right. Now I can kind of run it from here straight away. I'll just list all the files here. So I have listen to stuff.py and say something.py, and since these are Python scripts, I'm just going to type python 3 say something.py here, and well, that would basically wait for my keyboard input. And over here I'm gonna run python 3 listen to stuff.py. all right, I don't really see anything happening here, but again, this particular node would wait for you to enter something. Hello. Now that hello is printed over there. See, this one just published this hello thing, and this is our subscriber. It printed that hello that we received from the publisher. Now again, I can just keep sending random stuff. So it essentially does that. Now let's just list all the topics and nodes here, right? So ROS2 node list would show us all the nodes that are active, and our publisher and subscriber nodes are here. By the way, this is not exactly the name of the file that you were editing here, right? So this is not the name of the Python file here. The Python file had a somewhat weirder name. That was, what was it again? Say something.py. That's not really the name of the publisher. And listen to stuff is most certainly not the name of the subscriber. But you can actually see something. You can gedit say something.py, and you can see that this is the name of the node. This user input publisher, this is the node name, which is not really the name of the file that it resides in. I don't know, I just thought it was pretty cool, so just had to get this out of my head. Okay, so we listed all the nodes. We could do that again. ROS2 node list. It essentially shows you the nodes that are active, the subscriber and the publisher. All right, so what are the topics that are active here? I'm just going to type ROS2 topic list as before, and parameter events and ROS are going to be there, like I said, for everything. And this is our very own topic that we made, and that's here, UG26 matters. Let's just look at the same thing from RQT. So I'm just going to open RQT graph, and here it is. I could just basically list all the nodes and topics that are active. So I have my user input publisher node here, communicating to the message subscriber node here through this topic, which is UG26 matters. Even now, these files are not really executable. We are still using Python, running them like 2 Python scripts, although we are using all the some of these functionalities from RCLPy. We are still running them pretty much like how we would run 2 regular Python scripts, right? With Python 3, space, whatever file name, that way. So we could just modify the permissions to make these files executable. So plus X, again, what was the file name again? Say something.py. Say something.py. And if I list everything, you could see that say something.py is in green. Now that means that file has been modified into an executable form. All right, so I could do the same thing with the other file, right? That's the listener node here. Listen to stuff.py, and if I list everything, I have 2 executables. Now to run an executable, I just have to do this, say something.py. Okay. Now that was an awkward pause, right? I went silent. I didn't really know what was going on. All this stuff just popped up in my terminal and I kind of got scared. Okay, so here's what happened. I made an executable by modifying the permission, making it an executable file and everything, but I hadn't added a shebang line. So as a standalone executable file, it didn't really know what interpreter to use to, well, run the script, right? So it's actually something you can fix really simple. I just have to edit that file. I had added this one line, this is the shebang line, and I've specified what interpreter to use. That was pretty straightforward to fix. What do we have now? Can we run it? Probably yes. Let's see. Say something. And it does work. Let's do the same here. Listen to stuff.py, and I could I just had to do this. So I could just send data from the publisher node, and the subscriber node would receive it over the topic, and it would still display everything neatly. So these 2 things are still run from the terminal, and not exactly in a way we want to run ROS2 scripts, right? Say if I type ROS2 run package name node name, it still doesn't run like all the pre-built packages and nodes that we've used. So we want to kind of get our nodes running that way. So how do we do that? All right, let's just go back to our workspace. ROS2 workspace, and we have our source folder here, and we have our package inside that. And we see once we open that package directory, so this is the first directory with that name, by the way. So because this directory again contains another directory by the same name, so don't get confused here. Don't get confused. Just use the just enter the package directory, and you would find the script setup.py, and that's the one we're going to edit to make our files uh, run like generic ROS2 functionalities. Alright, so I'm just going to type gedit uh, setup.py. Now, here I have my entry points. Now, all this stuff, we'll get to that later, but these are my entry points. And what I'm going to do here is that inside quotes, I'm just going to add my node, right? So this setup file is for my package, and I'm just going to address this node by a different name. I'm just going to call this the talker node. So talk is going to be my talker node. I have to specify the package name. So this is first package, then dot the file name, right? Say something is the file. I don't have to specify the .py thing here. Instead, I'm just going to specify what function to run from it. That would be our main function, right? So that's one. So this, once I save this thing, and I'll open a different terminal here horizontally. I'm splitting it again. All right, so I'm just gonna go to my ROS2 workspace. I'm just gonna call const build here. Because we have made modifications to the package, I have to build it for the package to show all those differences. Alright, so when I'm building it, it shows something again, and there's only one package within that workspace. That's the first package. So I have it here. So from now on, all the ROS2 command tools should work, right? So ROS2 run, again, package name would be first package, and our executable name, our node name here, I've named it talk, as you remember, and yeah, sure enough, it works. But we also have to build the listener node to see all the difference, right? Alright, so here I have my setup folder again, setup file again. I'm just gonna add one more line here. So I'm just gonna add a second executable. That would be first package says something. Listen to stuff. Listen to stuff. Now if I try to run it from this window again, I'm just gonna split it again. I'm just gonna try running it with ROS2 run, first package, then I think I messed up. I need to give a different file name here, right? So this is listen. Sure. So these have to be different names, right? So talk would be for the talker node, listen should be for the listener node. Alright, now that I've shared these two, I could run listen, and there's no executable found. Why is that the case? Well, there are a bunch of reasons. First of all, we haven't really built the environment again, so I have to run that call. I have to go to my workspace, which I'm already in. I'm just gonna build that again, and this time around again there's just one package, but there are two nodes inside this package. Now if I run the same command, yeah, sure enough it works. And is it really working? Yes, it is working. You see, whatever I published, whatever I gave as a user input got published by the publisher node, and that got the subscriber got it, and that's just being printed to the terminal. Everything works. If I'm to just clear, I think I'll just open a new terminal here altogether, and if I'm to run, just two terminals here, ROS2 run, first package talk, and ROS2 run, first package listen. No, it works. And as before, I could list out all the nodes and topics. ROS2 node list. I will have all the list. I will have both the nodes listed here. I could list out the topics as before. Topic list. Okay, sorry, my bad. And I have, well, parameter events, ROS out, and the node the topic we created. And again, I could just run our Qt graph. And we have everything, and everything just works. It's 6 o'clock in the morning, and I'm really happy that it works. It's 6:30 actually. Have to pull an all-nighter. See you in the lab.